action. Vision for action processes are perceptual processes in the sense articulated above. They occur in the dorsal stream, which starts in the occipital lobe and then runs upwards, so from here upwards through the parietal lobe. These processes prepare the subject for immediate or online action, since they are triggered by sensory stimuli that dispose the subject to act. These processes are perceptual processes. Moreover, as I have argued on earlier occasions, vision for action processes are unconscious processes. There is lots of evidence for the hypothesis that vision for action representations that guide immediate action are unconscious. For example, if an object suddenly changes location, subjects adjust arm velocity and trajectory in less than 100 milliseconds. This is not enough time for the human brain to consciously represent a change in object location or a corresponding change in velocity and trajectory. Further, when subjects are asked to use a minimally demanding vocal response, ta, to indicate their awareness of a change in object location, correction of movement occurs significantly faster than the vocal response. Corrections of trajectory and hand aperture occur within 100 milliseconds, whereas the vocal response occurs after 420 milliseconds. Studies of pointing and saccadic eye movement further indicate that subjects can correct saccadic eye movement and pointing faster than they can consciously perceive a change in object location. In one study, the researchers asked subject participants to point as fast and accurately as possible to stimuli occurring in the dark. In the first series of trials, the target leaped from an initial position to a randomly selected position. In the second series, the target made a second jump in the same direction as the initial leap. The subjects reported that they were unaware of the second jump, and they were unable to predict its direction. But while saccadic eye movement and pointing behavior were initially aimed at the target position after the first jump, both were instantly adjusted to fit the target's new location. Even though the participants had no awareness of the two jumps, they were evidently seeing and acting on both jumps. The findings indicate that the subjects updated movement trajectory and target location without awareness of the update. Similar results were reported by Jacobson and Goodale. They first showed that subjects could not detect a 3-degree shift in vision through prisms. They then monitored the subject's movements. Despite no reported conscious awareness of the shift in vision, the shift generated a modified hand path curvature. Empirical data have also shown that while subjects are unaware of relying on visual information about their hand prior to movement, they perform with greater accuracy when this information is available. Together, these findings indicate that the dorsal stream representations that constitute vision for action are inaccessible to consciousness. In sum, I believe Gasiunas is absolutely right that there are unconscious perceptual processes, but ordinary synesthetic processes are not instances of unconscious perception. The best candidates to be unconscious perceptual processes are cases of blind sight, cases of perception of externally presented graphemes by higher grapheme-color synesthetes, and vision for action.